One of the main topics in section 4.4 is percent change. And what we typically are doing is looking for a percent change in a given quantity that you start with. So a quantity either increases a certain amount or decreases a certain amount, and we want to know what the percentage of change in the quantity is. Here are a couple of examples. The dosage for a medication is increased from 20 milligrams to 30 milligrams. What is the percent increase in a dosage? So that one involves percent increase. The second problem involves a piece of metal when it is subjected to below zero temperatures. Shrinking will normally take place if the diameter of a steel rod shrinks from 0.02 meters to 0.015 meters. Meters is a metric measurement. What is the percentage decrease in the diameter? Okay, so how much does the diameter decrease, not as a decimal, but as a percentage? Let's see how we do each one of these. Nice thing about it is that in all of these percent change problems, we're always going to be using this proportion. And the proportion is very straightforward. It's the amount of increase or decrease, that's a certain number or quantity, divided by the original amount, whatever we started with, and that should equal the percent increase or decrease divided by 100. 100%, of course, is everything, which is actually the original amount. We started with 100%, which corresponds to the original amount, and the amount of the increase then will correspond to the percentage of the increase, which goes on the top of this fraction on the right-hand side. So, for example, in order to solve the first problem, we increased from 20 milligrams to 30 milligrams, okay? And so what is the amount of increase? The amount of increase is really 10 milligrams. And if you, let's put in our units here, milligrams. And the original amount was 20 milligrams. You notice that these units cancel out very nicely. That's why I hadn't written it in there, because that's what would have happened. On the right-hand side of proportion, what is the percent increase, which is x? We don't know what that is, but it is over 100. And then we cross multiply, and we do 20 times x is 20x, and then 10 times 100 is 1,000, and x equals 50. All right, so x is equal to 50. That means that the percent increase right up here should be 50%. Okay? Let's take a look at the next problem. This time we're starting with the diameter of a rod, which is 0.02, and it's shrinking to 0.015 meters. So in order to find out what the difference is, it starts from 0.02, so I'll take 0.02, subtract 0.015, and we're going to divide that by the original amount. What is the original amount? Is 0.02 meters. Each one of these are meters in the numerator and the denominator cancel out. And of course, we set that equal to x divided by 100. Okay. And I have to subtract here, so 0.02 minus 0.015 is 0.005 when I subtract. Then I'm going to divide by 0.02. That, as I write this out, and that's supposed to equal x divided by 100. Now when I cross multiply, I get 0.02 times x, and when I multiply 0.005 times 100, I wind up with 0.5. Last step is to divide both sides by 0.02, and I wind up with x equals whatever 5 divided by 0.02 is, which is 25. Okay? So really, x is 25, And of course, that means that 25 over 100 means that the percentage decrease was 25%. Okay. Best way to check it, see if when you start with 0.02 and then subtract 25% of 0.02, multiply those two together, start with 0.02, multiply 0.25 times 0.02 and subtract them and see if you wind up with 0.015. And you do. Okay, here's a problem. This is a slightly different problem. It's treated the same way though, using the proportion. A machine is able to output 2,000 volts per day. If the output decreases by 1.5%, how many volts will be produced? So it's obvious we're starting off with 2,000 volts, but the output, which is the number of volts produced or created, decreases by 1.5%. How many volts will be produced? Okay. I'll give you, if you'd like to, you could pause the video at this. I'll wait about 5 seconds here, and then we'll continue. I'll show you what the answer is. Why don't you try it on your own, and then I'll show you what the answer should be. So, using our proportion, the amount of increase or decrease, for now, let's call that X, and we have to remember that X is the amount of the increase or decrease, the number of volts. That's what that is. And how many are the original amount? Well, the original amount of its output really is 2,000 per day. Okay? And so we want to find out, in this case, actually X is going to be a number which is going to represent a decrease. And that's equal to the percent decrease, which is 1.5 over 100. Okay? Now we're going to cross multiply, and we get 100x equals 3,000 right here, and we get x equals 30. And so if you answer, there will be 30 volts which will be produced if we decrease by 1.5%, that's absolutely wrong. What we've done really, is we found out the amount of the decrease. How many? We found out that 30 volts, right? That's the number of volts that are decreased in the production. So normally if I start with 2,000, 30 is the decrease in production, the number of volts produced will be 2,000 minus 30, which is equal to 1,970. What that last part is about is you've solved the problem and you have to try to think about your answer, if your answer makes sense. Is that what's wanted for the answer in the problem? And the answer is no. If I asked you what was the decrease in output, what was the actual decrease in output, that would be 30 volts. But it says how many volts will be produced after we decrease the output by 1.5%. That would be 2,000 minus 30. Take your time, think about the answer, think about whether or not you're answering the question precisely.